Now let's move on to part 2. This is where we learn how to evaluate a regression model. We'll examine the relationship between SST, SSR, and SSE and introduce the coefficient of determination, R squared. These concepts tell us how much of the variation in the data our model explains and how much it doesn't. Once you understand them, you'll know whether your regression model is actually a good fit. Here's one simple equation to remember. SST equals SSR plus SSE. SST is the total sum of squares, the total variation in sales. SSR is the sum of squares due to regression, the variation our model explains. SSE is the sum of squares due to error, the variation our model doesn't explain. Together, these three numbers tell the complete story of how well our model performs. Now let's calculate SST, SSR, and SSE. Using our regression equation, we calculate y hat for each month. Month 1 gives us 47.16. Next, we square the residuals. That's y I minus y hat I squared. For month 1, the value is 4.67. Adding those across all 5 months gives us SSE equals 9.83. We also calculate yi minus y bar squared. Adding those together gives us SST equals 150. Now that we have SST and SSE, finding SSR is easy. It's simply SST minus SSE. 150 minus 9.83 equals 140.17. So it all checks out. SST equals SSR plus SSE. 150 equals 140.17 plus 9.83. Now, how good is our model? Really? That's exactly what R squared tells us. R squared equals SSR divided by SST. In other words, explained variation over total variation. For Sarah, 140.17 divided by 150 equals 0.9344. That's a very strong fit. In plain English, 93.44% of the variation in Sarah's car sales is explained by Instagram spend. The remaining 6.56% comes from other factors outside our model. Here's a practice question for you. Sarah's regression of sales on Instagram posts produced the following results. SST equals 150 and SSE equals 9.83. Part A, calculate SSR. Part B, calculate R squared and interpret what it tells us about the relationship between Instagram posts and sales. Part C, if a competitor's model had an SSE of 45 with the same SST, whose model explains sales better, Sarah's or the competitor's? Explain why using SST, SSR, and SSE. Take a moment and work through it. Let's work through it together. First, SSR equals SST minus SSE. That's 150 minus 9.83, which equals 140.17. Now, R squared equals SSR divided by SST. 140.17 divided by 150 equals 0.9345 or 93.45%. That's a very strong fit. Now compare that to the competitor. Their SSE is 45, so their SSR becomes 105 and their R squared drops to 70%. So Sarah's model wins. A higher R squared means less unexplained error and a better overall fit. If you're learning something, smash that like button. It really helps this video reach more students. Coming up next, part 3, one marketing channel. wasn't the whole story. Instagram plus flyers, two predictors, one model, and the golden rule of ceteris paribus. Subscribe so you don't miss it. Let's keep going.